So in this collab you will train your first model, which will be able to convert Celsius degrees to Fahrenheit. You can see the formula our model will learn right here. First, we need to import TensorFlow and NumPy and tell TensorFlow only to log error messages. As we've learned, machine learning is all about having the inputs and outputs and then train a model that learns how to map between these two. So here we have a list of Celsius degrees, those will be our input to the model, and the corresponding Fahrenheit degrees, which is what we want to teach the model to produce when seeing the input. Let's print these. Let's also learn some machine learning terminology. Our inputs are called features, the outputs are called labels, and during the training process we will feed our model with a pair of the input and the corresponding output. We call this a training example. Now it's time to create our model, which will consist of a single dense layer that we declare here. You can see that it takes 1 as an input. These are the Celsius degrees coming in. And the unit specifies how many internal variables this layer will have. We'll describe the details around this in a later video. And then we create our model consisting of this single layer, L0. You can also inline the layer declaration directly into the sequential statement, like seen here. Let's execute these. The next thing we need to do is to compile our model. Here we specify two parameters, the loss and the optimizer. TensorFlow uses these during training to find the best model. Finding the best model involves numeric analysis, and TensorFlow encapsulates all the complexity going on. So you can always specify mean squared error when dealing with this type of problem, and the Adam optimizer. The 0.1 here is called the learning rate. You might want to tweak this when training your own models. This tells TensorFlow how aggressively it should try to find the best model. Any value between 0.1 and 0.001 could make sense here. Let's execute the compile statement. Now it's time to train our model. We do this by calling the fit method on our model object and providing the Celsius and Fahrenheit input-output examples and a flag called epochs that we set to 500. One epoch is a full iteration of the examples we have seen, and since we had 7 Celsius and Fahrenheit mapping examples, our model will train for a total of 3,500 examples. Let's execute the training process. And as you can see, in very little time, TensorFlow was able to train the model. Let's display some training statistics. Using matplotlib, we can plot a graph of, on the x-axis here, the epoch that we're training, and on the y-axis, the amount of loss. In the beginning, you can see that the loss is really high, but the more epochs that we execute in the training phase, you can see the training loss almost going down to 0. That means our model should be doing a really good job at converting between Celsius and Fahrenheit. Using the predict model, we can now feed any degrees in Celsius, and the model returns the corresponding degrees in Fahrenheit. So if we execute this, you can see that our model returns 211 degrees in Fahrenheit for 100 degrees Celsius. And that is actually very good, because when using the formula, you can see that 100 degrees Celsius is 212 degrees Fahrenheit. So our model is doing really well. Remember, our model had no idea what the final conversion algorithm should be, but by using a very simple model with a dense layer and 3,500 training examples, it was able to figure out this algorithm. Pretty amazing. We can now print the internal variables or weights of our dense layers by executing this statement. As you can see, there are 2 internal variables and they almost match what's in the formula, 1.8 and 32. We have 29 here, which is pretty close to 32. We'll explain in a later video what's going on with these values. But just for fun, let's try this out with another model, where we have 3 layers, the first 2 having 4 units each, and the last one having 1 unit. When executing this model, you can also see it's doing really well. but you cannot clearly see the 1.8 and 32 in all of the internal variables. As I said before, stay tuned for the explanation of this. And that's it for training our first model. Please read the text in the Colab to get more information. And of course, execute and try it for yourself.